Hello students, welcome to IMS GATE Academy. But in the last session I explained Norton's theorem and also I have done the problems based upon them. So far I completed mesh analysis, nodal analysis, Thevenin's, superposition and also Norton's. In today's session, I am going to start maximum power transfer theorem. I will explain the theorem. After that, I will do certain number of problems. Surely you are going to get good idea about maximum power transfer theorem. Yes. Maximum power transfer theorem. Maximum power transfer theorem. But this theorem is very important. GATE point of view, even the students who wants to appear for the engineering service, this will be very useful. And also for any competitive exams, this theorem, from this theorem you can expect questions, I say. What this theorem says, suppose a network is given like this. There is a source voltage. Here I got Rs is the source resistance and also given one load resistor. Current passing through this RL, I want to take it as a I. This current is nothing but I. When maximum power can transfer across, the load is more important. That means the maximum power across the load can be written like this. Maximum power transfer to the load. Load is nothing but the RL. I square RL I can say. Power transfer to the load is nothing but I square RL I can write. What is I? Current passing through the network. I can be written as a Vs by Rs plus RL I can write. Rs plus RL we can write. That I can substitute here now. Maximum power transfer to the load can be calculated. I square is nothing but Vs square divided by Rs plus RL whole square, because I square is there now, into RL. When we can say maximum power is transferred to the load, whenever Rs and RL are equal, then only maximum power will be transferred to the load. I say maximum power transfers, maximum power transferred to load if Rs and RL are equal. This condition is very important. If these two are equal, then only maximum power will be transferred. If you are differentiating with respect to RL, directly that condition is available. According to maximum minimum, dP by dRL you find and equate it to 0. You will get Rs equal to RL directly. But I am putting directly here now. But a maximum power transfer to the load can be calculated Vs square by RL equal to Rs, Rs plus Rs, 2Rs whole square, 4Rs whole square into RL. RL equal to Rs I have taken now. Wherever RL is given, I have taken Rs. Square and Rs I can cancel. And finally, I am getting Vs square by 4Rs. But one point you have to remember here, this network appears in the form of what? This is one of the series network. Thevenin's equivalent circuit is of this form only. In the Thevenin's equivalent circuit, you will connect a VTH, RTH and RL will be connected. So it is just like a what, no, Thevenin's equivalent circuits. That is why I can write this Vs equal to VTH, I can write, it's not a mistake. Rs equal to RTH, I can write. From this point, what we can write directly, RL equal to RTH, RL equal to RS anyhow, RL equal to RS, RS equal to RTH only. I can write Vs square is nothing but VTH square by 4 RTH we can write. By using this formula, any DC network, questions will be solved easily now. But already you have done Thevenin's. That is why how to find VTH, how to find RTH, you know very well. The same work will be done here. Then calculated maximum power. I will do certain number of questions, easily you can understand. Yes, we can start doing the questions now. A problem is given like this. Find maximum power. Find maximum power. Maximum power transferred to maximum power transfer to RL. Is asking directly maximum power transfer to the RL. So the network is given as a resistor and one more resistor is connected this side. There is 1 voltmeter, then voltage source is connected here. That voltage source is nothing but the plus 20. This is 20 volts. And these two terminals are connected to 2 more resistors like this. This is given 2 ohm. This is nothing but same 2 ohm. This is 3 ohm resistor and this is a 4 ohm resistor. This terminal and this terminal connected to the load. This is RL. This is RL it is given. But I can put a name for this point is A, this one I have taken B. Thereby required maximum power transfer to this load is required. Values I will check once again, 2, 2, 3, 4, exactly correct. So maximum power transfer to the load is nothing but I gave the formula. DC network it is. PM maximum power equal to VTH square by 4RL, we know formula. Initially we need to calculate what is VTH, then after RTH we know. Otherwise directly we can find RTH initially. How to find RTH? What way you can determine RTH? Wherever voltage source is given, that must be shorted, no doubt. Wherever voltage source is given, that must be shorted. Here I got 2 ohm resistor this side. This side it is given with 2 ohm resistor. This side 3 ohm resistor. And this side we got as a 4 ohm resistor it is given. Wherever the load is given, that must be removed. It must be open circuited now. I can extend. This is A, this is B. When the view is made this side, what resistance is occurred you find? That is RTH. That is RTH. How I can find the RTH? Whenever A and B you are pulling, 2 ohms and 2 ohms are in parallel, 3 and 4 are in parallel. Finally, those two will come in series, no doubt. I say RTH is nothing but these two are in parallel. 2 ohm parallel means what I can get? 1 ohm only. 1 ohm. But these two are parallel, finally series 1 plus these two are in parallel, 3 4s 12 divided by 7. 7 plus 12 divided by 7. 19 by 7 I can get now. 19 by 7 equal to 2.71 ohms. It comes. 2.71 ohms. It comes. This is RTH value. Next one, what is required here now? VTH also required. How we can find the VTH? Wherever the load is given, that is to be removed. I will draw that clearly now. The 2 ohm and 2 ohm must be written as it is. This side I got a 2 ohm resistance. This side I got a 2 ohm resistance. And this side there is one source plus minus. That voltage is given as a, what voltage is given? 20 volts. This is 20 volts. Here connected with one more resistor, here with one more resistor is given. What is the value of each resistor? 3 and 4 it is given. This is 3 ohm, this is 4 ohms it is given. And still what is given? Load is to be removed. The load is to be open circuited only. This point is A, this point is B. But I want voltage across this AB. Voltage across these two terminals required. That voltage I wish to say it as a VTH only. Thevenin's voltage I can say. But I can say clearly now, VTH can also be called as a VA minus VB also we can put. Thevenin's voltage is nothing but VA minus VB also I can write. That is VTH. Now please watch, in between these two terminals it is connected with 20 voltage here now. How I can take plus 20? This node voltage I can say 20 volts. 20 voltage only now. One reference node is required. This I have taken as a what now? Grounded only here directly. A reference node is a must. But I can say VA is nothing but this voltage is VA. VA is nothing but voltage across this 2 ohm. Grounded only now. 20 voltage is connected, 2 ohms goes this side. It doesn't flow any current, it is an open circuit only. 2 ohms and these 2 ohms are in series. I can write VTH is nothing, VTH equal to VA is nothing but voltage across, this is a VA value, this point is a VB. VA is nothing but voltage across these 2 ohms. Whenever same current is passing across 2 ohms and 2 ohms, we can apply voltage divider formula. So VA is nothing but 20 into, I can write 2 by 2 plus 2, 4 I can write, minus VB. VB is nothing but voltage across 4 ohms because of the supply 20 voltage, this current will go and divide across the 4 ohms only now. It doesn't flow any current this side because it is an open circuit only, I can say that now. So as per voltage divider formula, I will get VB like this now, 20 into the resistance 4 divided by 4 plus 3, 7 I can get here now. There I can cancel 4, 4, 5s. So VTH I can write 5 to 10 minus 80 by 7 I can get here now. If you have taken LCM, 7 10 70 minus 80 possible. Finally VTH is nothing but minus 10 by 7 volts we are getting. That much voltage we are getting only now. Minus 10 by 7 equal to I can write this value minus 1.43 possible approximately. Minus 1.43 voltage I am getting VTH. Now you can determine maximum power transfer to the load. I gave already formula VTH square by 4 RTH I said already. The same formula I used here now. VTH is nothing but minus 1.43 whole square. 4 into RTH. RTH is nothing but 2.71. 2.71 I can write. And finally I am getting use calculator 0.188 188 watts possible. Watts possible. That much power will be transferred to the what now? Load according to maximum power transfer theorem. That way we can tackle now. But I want to give one more question in your hand. You please try and give answer. But I want to give one more question here now. A problem was given like this now. Find value of I. Find value of I is asking to find I value for maximum power transfer, for maximum power transfer, in the current source, in the current source, in the current source. Here the network is given here like this. Now source voltage is given here Vs, this voltage is Vs, and connected with Rs, there is a resistor Rs, and connected with one current source. That current source is nothing but I. It is given. Voltage across this current source is given V. This is V only now. This is one of the gate question. Anybody can complete this question without my help. What is asking? Find the value of I. I value is required. At what particular condition is asking to find the current I? When maximum power is transferred from the source only now. Whenever maximum power is transferred to this current source, you find out the current I. That is the given problem. But you please try, I will give you some time, please try to complete this question. I will see any student is going to complete this question or not. Please try it. You can try initially. Anybody can give answer for this question without my help? Anybody? Any students are present? Can you respond? If any student is present, please respond. What way we can find current I? Yes, I will do. Please watch. What we have to do is power transfer to the current source equal to voltage into current. Voltage into current is nothing but power transfer to the what now? This current source I can say. I want to put like this now. Power equal to voltage into current. I can write directly. Voltage into current now. But this voltage equal to what? This voltage how I can get? Vs minus drop across this Rs is nothing but V. What is drop across Rs? I into Rs. Vs minus I into Rs is nothing but V. I can say directly. So I want to substitute here now. Voltage is nothing but Vs minus I into Rs. This is nothing but the V. This minus this into I. This current I have taken as it is. I have taken I as it is. But I would like to multiply this I. If I multiplied, I can get Vs into I minus I square into Rs, I can get here now. So when maximum, I want the current I, when maximum power transfer to the what now current source is required. So differentiate this power with respect to I and equate to what now 0 according to maximum minimum. then you can determine I value. What I say is differentiate on both sides with respect to I, dp by di, we can calculate. I derivative 1, I will get Vs. I square can be taken 2I into Rs, I can write. This must be equated to 0, no doubt, according to maximum minimum. Now I can find this equal to 0 means what is I? 2I Rs equal to, I can write 2I Rs equal to what? Vs is possible. Then what is I? I equal to Vs by 2 Rs I can write now. So when maximum power is transferred to the current source, the current which passes through this network is nothing but Vs by 2 Rs I can say. This is the answer for this question. I think students might have followed this question. Question and solution you followed, I hope it now. Now I want to give one more question, you can understand clearly now. I wish to give one more question in your hand. What is the value of R? What is the value of R? Is asking to find R. What is the value of R required for maximum power transfer? For maximum power transfer, I can say. Maximum power transfer in network shown below. And here the network is given like this, 25 volts battery is given here now, 25 volts. And here 5 ohm resistor is connected here. There is one 5 ohm resistor and 20 ohm resistor this side. This is 20 ohm resistor. And there is one current source. That current source is given as like this. Its value is nothing but 3 amperes. This is with 3 amperes. And there is one resistor 4 ohm here. And load is connected this side. There is RL. Yes, the problem was given here now. This is the RL is given. I will check the values 25 volts, 5 ohms and 20 ohms and 3 amperes and 4 ohms and also R is given. Yes, anyhow in the problem what he is asking? Is asking to calculate RL value when maximum power is transferred to the what? No load. What way we can find the RL? RL equal to what I said? RTH also. That's why if you got the Thevenin's equivalent circuit, in the Thevenin's what methodology you applied to find out the RTH, you watch it now. Then you can determine RTH easily now. What is the condition is given to find the RTH? Wherever the voltage sources are given, DC voltage source is given, that must be shorted directly. If it is an independent source, you short circuit. If there is current source, that must be open circuited only now. That condition must be applied in a problem. What I say is, wherever voltage source is given, that must be shorted. I can redraw the network like this now. This voltage source is shorted. There is one 5 ohm resistor and 20 ohm resistor this side. 20 ohm resistor. Here I got the current source. That current source must be open circuited, you know very well, because wherever the current source is given, that must be open circuited now. This is open. That can be removed. And there is one resistor that is nothing but 4 ohm this side. This is 4 ohm resistor. Wherever the load is connected now, that must be open circuited here now. When the load is removed, between these two terminals, when the view is made between these two terminals, what resistance you can get, that is more important. That can be taken as a RTH value. By means of simplification, we can get RTH directly. When you want to find out the RTH in this direction, you reduce the network in opposite direction. These two are in parallel. The final value will be in series to the what now? 4 ohm resistance only. It comes in series. I can write RTH is nothing but these two are in parallel, 20 into 5, 100 divided by 5 plus 20, 25 plus in series to the what now? 4 ohms. 25 4s we can cancel. 4 plus 4, 8 ohms I can find. This is the RTH is equated to RL also. RTH and RL are same, I said now, as per maximum power transfer theorem. That way we can tackle this question. Yes, I want to give one more question in your hand. You please try this. The one more question I want to give. Now, initially you try this question, I will give in your hand. I want to give in your hand initially. Find maximum power delivered. Find maximum power. Maximum power. Find maximum power delivered. Delivered to the resistor RL. To the resistor RL is dash. Here given like this, the network is given like this, 2K resistor that is connected with one voltage source, 20 volts. Polarity of this battery is given, this is minus, this is a plus. Here connected one more resistor with one more battery, but this polarity is given plus and minus this side. That voltage source is given 30 volts and also the value of that resistor is 2K here. And here connected one more battery, minus and plus. This voltage is given 5 volts. The load resistor is given like this now. Here connected like this, RL. This is RL. But thereby required RL value. When maximum power is transferred to the RL, you find the maximum power only. It's not asking RL, sorry. Find maximum power delivered to the RL only now. Maximum power equal to what for DC network? PDC equal to VTH square divided by 4RL, 4RTH we can write now. Initially you find VTH and also RTH. Both you try to find. Please start doing this question without my help. Please start your work, but I want to wait for some time. You please try this question. You please try. I think you can tackle this question easily. Once you got the concept, easily you can do. Find maximum power transfer to the RL. But how to get its value? But initially we can try for the VTH. To find the VTH, what you have to do? Wherever RL is given, that must be open circuited. Open circuit voltage is nothing but VTH, we know very well. What I say is, in the given network, all these elements are to be taken as it is. Even the resistor or battery is given, that must be taken as it is. This is with 20 volts. This side it is connected with 2K resistor and also connected with 30 volts here. This is with 30 volts. But here connected with one more source, minus and plus with 5 volts. Load is to be removed. Wherever load is given, you remove it. The voltage across these two terminals is to be taken as a VTH. How the polarity is to be taken? Plus, minus only here. How we can determine this VTH means just by applying the KVL you can get now. Just apply the KVL in this direction or even in this direction, you will get answer now. But if you want to get that VTH, current across this 2K is very important. Without knowing the current across 2K, I cannot determine VTH value. I wish to denote current passing through this 2K, I wish to denote as I. This is open circuited only here now. When the current is passing up to this node, it doesn't flow any current this side. The reason is it is open circuited now. The same current will divert this side I. Even here also same I will flow. In this case, directly I can apply the KVL in this path. Just I want to apply the KVL in this path to find I. How I can take? Supply voltage equal to sum of the drops only now. 30 voltage equal to, I can write this voltage equal to drop across this 2K into I. When I go this side, 2K into I again. 2K into I can get. When I go down minus sign, I got minus 20, I can put here now. Yes, such a way equation is formed by using the by using the KVL only now. 20 if you brought this side, it becomes a 50. This side 2 plus 2, 4K. K is nothing but 10 power 3 into I is possible. And finally, I equal to 50 by 4 into 10 power 3, I can note out. If you are using the calculator, you will get this value as I equal to 12.5 milliamperes of current you will get. Milliamperes of current is possible. 12.5 milliamperes of the current is possible. Once you got this current I, this current is I said now. You can determine VTH. Just apply the KVL in this path. In this path, I will apply the KVL again to find the VTH. I can write VTH equal to what? When I go this side, plus 5 volts I am getting here now. Plus 5. When I go this side, some drop. What drop? This is a plus, this is a minus is possible. Minus of 2K into I. Minus 2K. K is nothing but 10 power 3. I is in 12.5 milli. It's a milli given. We got milli only now. When you go down, plus 30 I can get here now. Plus 30. Plus 30 I will get here now. But I would like to simplify this now. If I simplified, what I can get here now? What is the value is available? VTH is nothing but 5 minus 10 power minus 3, 10 power 3 cancel. 12.5 into 2, 25 I can get here now. Plus 30 I can get now. So finally 35 minus 25 I can get now. I am getting the 10 volts finally. I got VTH as 10 volts here now. Now I want to find what is RTH also. After getting the RTH, I can find power transfer, maximum power transfer to the load. So to find the RL, what you need to do, wherever the voltage sources are given, they must be short circuited. I want to redraw this network. What way you can redraw? There is one 2 ohm resistor, 2 ohm or 2K, sorry, this is a 2K resistor is connected here now. 2K resistance is connected here now. 2K here now we got. This is a 2K. Here I got one more 2K resistor. But these two voltage sources are shorted. Two batteries are connected there now. Those two are shorted. If they are shorted here now, what I will get? These 5 volts also shorted here now. I will get only RL. RL must be open circuited only now. Wherever RL is given, that must be open circuited here now. This must be open circuited like this. This must be open circuited like this only. And you can determine what is RTH here now. When the view is made this side, when the view is made between these two terminals, you will get the RTH only now. You know very well, 2K and 2K are in parallel. RTH equal to 2K parallel to what? 2K one now. And finally, it becomes 1K, mostly possible. 1 kilo ohm we are getting. Now we can determine the required value of maximum power across the load. This is nothing but 4TH square by 4 into RTH, you know very well. This formula is applicable directly. VTH we got already. How much we are getting? VTH equal to 10 voltage. 10 volts it is given. 10 square divided by 4 into RTH. RTH is 1K. 1 into 10 power 3 I can write. So 10 square is 100 divided by 4 into 10 power 3 I am getting. Finally, it becomes 25 milliwatts possible. 25 milliwatts of power will be transferred to the load only now. That is the answer. Followed? In that way, we can tackle this question. But I want to give one question by using dependent source also. Then you are going to get some idea how to do problems with the dependent source. You will understand. Next question. In the following circuit, question given like this. In the following circuit, what should be the value of RL? What should be the value of what should be the value of RL, R suffix L, such that maximum power transfer takes place. Power transfer takes place. It is given. Takes place. And the circuit network is given like this. There is a voltage source here. That voltage source is given 36 volts. And 2 ohm resistor is connected here. One 2 ohm resistor is connected here. And 6 amperes of current is connected here now. This is 6 amperes. This is with 6 amperes, I can say. 6 amperes. And one dependent source is connected this side. One of the dependent source is connected this side. Its value is given 2 VA minus n plus 2 V suffix A. I can write. And one 2 ohm resistor is connected this side. This is 2 ohm resistor. The load is connected here. This is RL. This is RL. The voltage across this 2 ohm is given V suffix A. With polarities plus and minus, it is given. This is the given problem. I'll check the values once again. 36, 2 ohms minus and plus VA, 6 amperes, 2 VA minus and plus 2 ohms and RL. Yes, anybody can tackle this question? Anybody can solve this question without my help? Is asking to find RL. RL equal to what? RTH, you know very well. RL is nothing but RTH, you know very well. You compute the value of RL or RTH. Start doing this question. You can start doing this question. Anybody can do this? I would like to wait for some time. Anybody can give answer? What is the value of RTH from the given problem? Okay, I will do, please watch. But I want to redraw this network. To find out the RTH, what you must do? Wherever DC voltage source is given, that must be shorted. If there is any dependent source, in the networks, that must be taken as it is. That should not be disturbed. What I say, the current source, whatever it is given, that must be open circuited only now. You can redraw network like this. The voltage source you short, I said now. There is one resistor that must be connected as it is. That is 2 ohm, it is given here now. This is 2 ohm with a polarity plus and minus, that is a VA is given here. And there is one current source. That current source is to be open circuited, I said now. If it is open circuited now, I will have only dependent source now. The dependent source 2 VA, I have taken here now, 2 VA. This is 2 VA, I can put like this. Minus and plus, this is a 2 VA is given here. What else it is given here now? 2 VA. And 2 ohm resistor is given this side. I will connect 2 ohm resistor also this side. This is 2 ohm. Wherever the load is given, that must be open circuited only now. This is removed. The load is removed only now. But here, you catch the point. When dependent source is given, I explained already in Thevenin's. What way we can find out the RTH? But I want the resistance across these two terminals. Resistance across these two terminals is more important. The resistance across these two terminals are required means you try to connect one voltage source or current source in between these two terminals. But I selected a current source of 1 ampere here. If you selected across these two terminal, current is a 1 ampere, voltage across these two terminals, you try to take it as a V, that is unknown value. That is unknown. My aim is to compute the resistance across these two terminals. Resistance across those two terminals is nothing but RTH, I can say. The voltage across these two terminals divided by current. Voltage across these two terminals is nothing but the V divided by 1 ampere, V by 1. So once you know the voltage V, easily you can determine RTH here now. How to find out that V is more important here now? How we have to find mean this node voltage is nothing but same V. We don't have any other resistors in between these two. This is V, we know very well. But I wish to apply a nodal analysis. in this problem here now. If I apply the nodal analysis, I can take current direction this side. This current plus, this current plus, this current equal to 0, I can equate. So what current is passing this side? Current across this 2 ohms required. V minus of 2VA divided by 2 is required. I will use V minus 2VA divided by what? 2 ohms. Difference of this voltage divided by resistance across these two terminals. Plus current across this 2 ohm is nothing but V by 2, I can put here directly. V by 2. This current is nothing but the minus 1 ampere because the current direction is in reverse. As the current direction is in reverse, I can put minus 1. This is equal to 0 here now. But what about that VA? To get VA, we need to eliminate, to get the V value, VA is to be eliminated only now. How I can get? I can say V is nothing but this voltage equal to this voltage plus this voltage drop only now. If I apply the KVL in this path, but this is equal to what? This is a grounded only now. V equal to this voltage plus this voltage only possible when I apply the KVL in this path. V equal to, I can write 2VA plus VA is possible here. V equal to 2VA plus VA is possible. That equal to 3VA. We can note down here now. 3VA is possible. This I want to take it as equation number 1. This is equation number 2. Substituting equation 2 in equation 1. You can substitute directly here now. Substituting equation 2 in equation 1. In equation 1 I can put here now. What happens now that I want to take this, don't take a VA, you take it now, that's still good now. Still it is better now. What is VA? You put it now, best. So here I will get now VA is nothing but V by 3 I can get now, V by 3. This I want to take it as equation number 2 because my aim is to find the V. That's why I want to eliminate VA from the given equation. But I can write V minus 2 into VA is nothing but V by 3 divided by 2 plus V by 2. This is equal to 1 I can write. Then you can simplify 3V minus 2V. 3V minus 2V, V only possible. V by 6 I can get here now. Plus V by 2 equal to 1. V by 6, that much value possible. Take an LCM, you will get the required result only now. Yes, to simplify 3V minus 2V is nothing but that much you are getting now. 3 into 2, 6V by 2 we are getting here now. And finally here 6 is LCM here. V plus 3V is possible. That equal to 1. 3V plus V, 4V equal to what? 6 into 1, 6 possible. V equal to 6 by 4 is possible. And 2 3s and 2 2s I can write now. Voltage is nothing but 1.5 voltage I can get now. 1.5 voltage. By using this voltage, we can determine RTH. This RTH is required. I can write RTH equal to what? V by 1, we know. V equal to what now? 1.5 by 1, 1.5 ohms it is possible. This is the final answer for this question, I can say. I think you followed the theorem of maximum power, and I did certain number of problems for the sake of your understanding. Thank you all.